People need to realize that animals get cancer and that owners want their animals cured and cared for, and that why not extrapolate that to humans.
This is an opportunity for us to help the human population with cancer, the canine population with cancer, and the owners of the canines and the family members of the humans. Everyone benefits. In a sense, that's what this whole Moonshot announcement is about.
Time matters. Days matter. Minutes matter.
Focus on cancer, that is all about breaking down barriers and developing new ways to test and develop drugs more quickly and more efficiently.
If our companions could play a role in that, that opens up even more opportunity, because we're not going to get where we need to go if we're going to keep doing things the way we always have.
The more I thought about it, the more I dug into it, the more I talked to people, the more I read, the more identical these diseases are, despite the fact that they occur in different species. And that is such a powerful tool. So why shouldn't we really dig into that deeper?
We look at our companion animals all the time as these heroes. They are search and rescue dogs, but we never think of them in the capacity of patients who enter clinical trials, who could someday participate in one study that saves our life or my child's life.
We don't give dogs cancers, they get the cancers naturally, spontaneous diseases, as we do. Man's best friend is probably also man's best new biomedical friend. And I firmly believe that the answers to some of the nature's most intriguing puzzles about cancer is sitting in that four-legged friend that has been walking beside us for all these years.
Maybe someday lymphoma is not going to be a death sentence for you. You know, it may be manageable is what I hope. Because nobody deserves this, especially a 6-year-old little cocker.
Pet owners get it. Like, they understand that dogs get cancer. The medical community doesn't always understand that. I don't think they understand the rates of cancer. I don't think they understand how many dogs get cancer.
1 million dogs develop naturally occurring cancer annually, and 50% of dogs over 10 die from the disease.
They are patients, just like the two-legged patients are. And so anything that we do with these animals always has to be thought in the context that there is a potential benefit to them.
Tail seems to be working very well.
The reality is that we seek cures and prevention for tomorrow, and we must pay attention for the patients of today.
In the fight against cancer, we need all the allies we can get. Enlisting our best friends to help might give us our best chance at victory.
It's not supposed to replace human cancer research or lab animal research, and this is one more angle, and we hope that we change the trajectory to a cure up.
These people who are looking for breakthroughs aren't interested whether the breakthrough comes through a dog or a zebrafish. Just give us something we can work with, and we'll help speed up the process of drug development, which is so long and expensive.
The field of study is called Comparative or Translational Oncology.
So it went from, yeah, we think that dogs get cancer and we think it's important and we think it might look the same as human cancer, but that's maybe all we know, to now we have shared molecular targets, we have overlapping genomic heterogeneity, we have a lot more information that really we can hold up to the basic science community and to the cancer drug development community and say, this isn't just dogs get cancer. This is dogs are a really important and relevant opportunity to refine the drug development process and to save time and to save money and ultimately to save lives.
Motivated dog owners committed to do whatever it takes to save their pets are unleashing a powerful new strategy to conquer cancer.
Hi, Riley. Hey, bud.
Riley Schmidt battles a bone cancer known as osteosarcoma. He had his original tumor managed through amputation.
It was never an option for us just to do palliative care. We knew we would lose him. I think the average is about 70 days or so. Yeah. We just couldn't do that.
Judy Walker also battles osteosarcoma.
When they finally told me what it was and what I was facing, I asked them, you know, am I fighting for my leg or my life? And that nurse looked at me and said, both.
She benefited from a limb spare technique first developed in dogs.
I didn't know anything about osteosarcoma. When the doctor called me to let me know what he thought it was, and of course we immediately started looking everything up that we could on it. One of the first things that came up was a piece that had been done with Dr. Wilkins and Dr. Withrow and the collaboration that they had going on.
Imagine you are facing life-saving surgery. Your doctor decides to consult a colleague about your case. Not just any colleague, a veterinarian. Now that might shock.
And generally the veterinarian and human medicine, fields are separate and don't communicate. But it's a tragedy because this translational medicine, which benefits both species, is so important and it's so logical.
The fact that I got to keep my leg was a total gift. I was on crutches, but we went to Costa Rica and put my toes in the sand, and I took a picture of my feet, and I sent it to Dr. Wilkins and said, I have my toes in the sand.
Dogs continue to inform Judy's journey.
My story is not over yet with this illness. I've had 2 metastases to my lungs.
To keep his cancer at bay, Riley entered a clinical trial at Colorado State University's Flint Animal Cancer Center.
The fact that it's being translated into the human side is just another big plus for us.
The trial, designed to help Riley, could potentially also help Judy.
I am hopeful that they will find something to treat the lung tumors that I have, because we really don't know what the next thing is that would work to stop those.
The clinical and cellular connections between Riley and Judy elevate the human-animal bond story to a new plateau.
Osteosarcoma is a terrible disease. Thankfully, fewer than 1,000 kids diagnosed every year with bone cancer. When we look at dogs, historically the number's always been greater than 10,000, but through our recent surveys, it's probably more than 50,000 dogs a year are diagnosed with bone cancer. So it's a two-edged sword. Is on the one hand, by working with dogs, we can actually identify a greater population size from which to identify the genetic changes. And because we've shown that the genetic changes are shared between humans and dogs, it adds to the 1,000 or so patients from kids that get bone cancer every year. Basically, don't look at humans and dogs as separate species. Look at them as 2 partners that share the same cancer.
So there's still this great barrier, I think, we have in communicating the similarities between the species.
The reasons for any kind of barrier remains elusive. Far from a recent phenomenon, dogs have been routinely treated for cancer for more than 50 years.
That old saying, on the shoulders of giants, we look tall, and so there are a lot of giants that have made this happen.
The first veterinarian to use chemotherapy to treat cancer in dogs, Dr. Gordon Thielen, ranks as a pioneer in the discipline of comparative oncology.
I would prefer a forefather.
I was reading Gordon Thielen's papers as a graduate student at Colorado State, and these foundations really got me curious as to what causes cancer.
The most important thing about the dog, it lives in our environment. There's no other animal that's been domesticated as long as the dog, somewhere around 30,000 years.
Dogs have also played a role in major clinical breakthroughs over those 5 decades. Rainer Storb, a world-renowned scientist at the Fred Hutchinson Cancer Research Center in Seattle, developed the original bone marrow transplant technique for people with the help of dogs being treated for lymphoma.
When we started our human transplants, we patented exactly on the way we treated our dogs. And it was remarkably transferable, actually. In our field, certainly, the transplants wouldn't have happened had we not had this dog model. It just simply wouldn't have happened. What helps in the dog is definitely going to help in humans. And so that has been our philosophy all the time, and it just seemed to work.
A deep level of caring and the strength of the unwavering human-animal bond has helped move the field forward.
Why do I do what I do today? probably starts from when, as an 11-year-old, our family dog died from what we thought at the time was a liver cancer. And at that time, I remember I was horrified by the fact that the veterinarian, as good as he was, well, what do we do? There's nothing we can do. What we can do is merge together the dog patients and the human patients. It's an opportunity that will yield tremendous benefit to both dogs and people.
Sometimes something can be done, as in the case of Emily Brown. Emily was given 3 months to live when she was just 11 years old. The culprit, osteosarcoma.
As an addition to all my traditional therapies, my parents and I had decided to enroll in a clinical trial. And that clinical trial was MTPPE.
What people want to know is, what hope do I have? In this particular case, we could tell her some good things. We said, we're hopeful. There is information that we have based on the dogs who have been treated with this agent in combination with other chemotherapy that make us think this could be better.
Survival rate in animals went up. I think it was like 20% more. I mean, it was significantly higher. When I was diagnosed, you had 50-50 odds of surviving osteosarcoma. I don't know how you could say no to that.
Well, my opinion is it saved Emily.
How do you feel? Good. There you go.
Emily learned how dogs saved her life while attending a summer camp for kids with cancer run by a veterinarian oncologist, Dr. Steve Withrow.
And he came up to me and said, "You're Emily Brown." I'm like, "Yeah, I was involved with your care." You're a vet. There's no way you could have been involved in my treatment. He goes, "I was working with your doctor and we collaborated." And so many years later, we have a great friendship because between him and their human counterparts, they were the ones that came up with the ideas to help save me.
We're very lucky here because this is our neighbors have had a hand in developing this, and so we have resources that are easily accessible. It's a great group of people. They want things to be successful. And so the sense of community actually really broadens, and that's true for the cancer community in general. It's particularly true for the pediatric cancer community, and it's very true for the Colorado cancer community. And that, to me, is really sort of a magical intersection between all of those things that really, for any one family, just matters what happens to their kid.
We got to figure out how to get out of your way, and you guys have to figure out how to get in each other's way more.
The Moonshot Proposal, championed by the Obama administration, has refocused the fight against cancer with a renewed hope for accelerating discovery.
Despite the fact that I love dogs, I could never justify this kind of effort and interaction simply based on my own interest. I really firmly believe that closer collaboration in our study of how cancers form and how to treat cancers in these two populations will be mutually beneficial, and in fact affords us opportunities that we simply do not have with other cancer models.
Make a decade's worth of progress in the next 5 years.
The collaboration with our companion animals may be the catalyst to answer the call for exponential growth. There are events and programs providing infrastructure already in existence. The National Cancer Institute established the Comparative Oncology program and the Clinical Oncology Trials Consortium in 2003, bringing together veterinarian oncologists from across the country.
We've always been rowing in approximately the same direction, but we may not have been rowing synchronously. And so I think that, for example, the Comparative Oncology program has been a tremendous catalyst that was started by Chan Khanna that really has been extremely influential, extremely important for coalescing these comparative oncologists.
So we got rapid and early buy-in, which was good, and that allowed us to then do a couple of studies that then were published. And I think that what then happened is, because we're collaborating and using best practices, that the level of science done before a dog trial, sort of the science done at vet schools began to progressively rise for many reasons. And so I think that's been a maturation in the field. And I think the outcome of that is more veterinary scientists receiving funding to do these studies.
It can also is very helpful in that our caseload, we're talking about multinational and in some cases international trials where we can bring to a larger companion population with the same type of cancers so that we can increase the power of the data those pets help us produce.
A recent workshop at the National Academies in Washington has raised awareness within the entire biomedical community.
I think the workshop was a milestone event in the awareness and validity of going to the next level.
The trial is giving the dog hope that the dog might otherwise not have.
The meeting, facilitated by the Institute of Medicine, engaged basic and applied science investigators from both the human and veterinary communities.
I think the recognition now is great. It's coming from the National Cancer Institute, it's coming from other cancer research organizations, and there truly is a growing appreciation for this type of work and how important it is.
I want to express my appreciation on a personal level on behalf of the American Cancer Society.
American Cancer Society Deputy Chief Medical Officer Dr. Len Lichtenfeld lost his beloved golden retriever Lily to cancer the week before speaking at the Iom Workshop.
Several days after we agreed to participate, this is dog's name is Lily. It's our pet. She was with us for 11 years. I didn't think this would happen, but it's happening.
I started to cry. But maybe that says it all, what it all meant to me. That's when it really struck me. The personal loss, the science and what could be done, the opportunities, and the commitment of the people who were in the room to talk and study and learn and listen.
As we leave this room, let's commit to taking a look at those potentials, determining what they are, and making that happen. Thank you very much.
Losing Lily strengthened Dr. Lichtenfeld's commitment to do more and to do it quicker.
It was impressive to show that there was some very measurable activity of PAC1 doxorubicin in a spontaneous dog model.
The utilization of dog studies can accelerate drug development. A cancer compound called PAC1, discovered by a chemist at the University of Illinois and investigated in dogs with cancer by a veterinarian oncologist at the university, serves as an example of how comparative oncology infuses energy into the drug discovery and approval process.
We've been very fortunate to actually have a successful startup company called Vanquish Oncology that took a prototypic drug called PAC1 that was discovered in Paul Hergenrother's lab in 2005, and he ultimately published his paper in 2006 in Nature. That was a small molecule that would activate cells to die, and it preferentially targeted cancer cells.
The dogs were critical as a link to move what we had seen in our laboratory and in mice forward to humans. It put everything on fast forward, no question.
The path that PAC1 has followed from basic science discovery to preclinical evaluation to dogs with cancer to humans with cancer is a beautiful blueprint to follow.
I can't overestimate how hard it is to attract money to go over the hump into human clinical trials. They call this the valley of death, where you have a compound that works in cell culture, and maybe in mice 99% of these drug candidates never get tested in humans because it's such an expensive proposition to get into humans. And so having this data in veterinary cancer patients enabled us to attract this angel investor, which ultimately enabled everything.
At day 70 and looked for any tumor cells, there were none.
At the Silicon Valley startup Omniox, a clinical trial in dogs cut time and added enthusiasm for a novel brain cancer product they're trying to bring to market.
We were able to use the clinical trial in canine brain cancer to accelerating our clinical timeline by about 5 years, and that saves maybe $50 million worth of clinical development costs in that time period. And it gets physicians excited because there's a chance from the very first patient that we could be helping cure their tumors. 1 month after treatment, here it is running around and playing. The excitement amongst the clinicians when we show the canine clinical trial is palpable. They go from being very skeptical to, wow, look, your therapy gets into the dog's cancers. It looks like it's active, it's well tolerated. You show pictures of the dogs getting treatment, in a hospital, this encouraged us to go to the FDA and argue for a more aggressive clinical trial strategy to shave years off the development.
Because unlike the medical community, where cancer patient outcomes can take 5, 10, 15 years to really determine, we often know our outcomes within 1 to 2 years. So there's a tremendous potential to ask really important biologic questions and answer them in a very short timeline.
Consider the span of time it took immunotherapy to take shape. The headlines announcing the breakthrough go back more than 45 years.
We covered Time magazine. It was about immunotherapy. That issue was devoted to the fact that immunotherapy was going to cure cancer. That was 1973.
Artist and cancer survivor Shelley Kerr just got the news this year.
I was diagnosed with bladder cancer, and after multiple surgeries and chemotherapy, finally reached a point where it was terminal, and the doctors said that I could have chemotherapy to prolong my life. And within 3 days, they had pursued the option of immunotherapy, and within 3 months, I'm cancer-free.
She's grateful for the miracle of timing and an oncologist willing to look outside the box.
And as a sculptor, there's a creative moment that will eventually end up being a very tangible thing in metal. What I see happening that is so wonderful with immunotherapy and all the researchers and doctors that are around that is that they're in that creative moment where they're starting to see results. All that hard work is starting to pay off. Now they're getting their tangible result. Let's find a way to continue to come up with creative solutions.
Companion animals with a similar immune system to humans can inspire the creative thinking needed to advance the study of these therapies.
The next big discovery really that we can contribute in veterinary medicine is to really begin to understand how to integrate immunotherapy approaches with standard of care modalities to really leverage the value of both and even further enhance outcomes. Like, it really has to be done in a biological system that is representative of what happens in people, and dogs are the closest things.
Bill Lukes understands the need for more options for both companion animals and humans all too well. Bill loved his dog Bogey, and like many owners, he did all he could to extend Bo's quality of life after he developed cancer.
I look at Bo, and I look at what he went through, and that they knew more after treating him than they knew before. I can tell you, I'm not wasting the lessons that I learned from him.
Cancer presents many ironies. Bill now faces a similar battle. He has stage 4 esophageal cancer. Surgery is not an option.
My only hope is to find a suitable clinical trial.
But we're all frustrated how long the process takes, how long it takes to go from a discovery to something that everyone will use to take care of a cancer patient. It's not that we don't have enough good ideas, it's that we don't have the wherewithal to test them all as effectively as we should. This is a perfect opportunity to take advantage of another patient population.
So we need to find a better way to do it. And it may well be, if we understand the cancers in our companions, if we understand the genomics, the genetic makeup of those cancers, that we may have a huge opportunity to help accelerate new drugs for the treatment of human disease.
I think people really need to realize that they have the power as a pet owner to really transform more than just their own immediate family. They have, far-reaching implications for our health and well-being.
I think dog owners can contribute immensely to our understanding of the basic causes of cancer.
If I were to say one thing to dog owners of America, and I think it's something like 1/3 of homes in America own at least one dog. You are uniquely poised to be part of probably the biggest experiment in human health that's ever been done. Because the chances that your dog, either as a case or a control, can make a contribution to study going on here, going on at any vet school in America, going on at research labs across the world.
I hope that people become more aware of this option, and if, God forbid, they get this diagnosis in their dog, that they go online and they see if they can get into a trial.
For pet and human patients, accelerated discovery, innovation, collaboration, and fresh new ideas provide the assets they can exchange for hope.
Because all we can really do is hope, but I think that when you take the expertise of the veterinary profession, the medical profession, whether it's clinical or basic researchers, by them all working together, there might be two sides of a coin, but it's the same currency.
The numbers remain staggering. 1 in 3 people, 1 in 4 dogs develop cancer in their lifetimes. The path to making cancer a more manageable disease may never be smooth or straight or obstacle-free, but it could be shorter and less of a climb if we look for answers from those walking right beside us.